Hi everyone, this is going to be a video on how to use quadratics to solve real-world problems. All of these problems are based out of real-world situations using context from data collected, and we're going to see how to use a quadratic graph and different parts of the quadratic graph to solve these and find solutions. So some general strategies we're going to look at is make sure you read the problem entirely and reread it until you understand it. The big thing is determine what you're asked to find. Are you finding the max and minimum using the axis of symmetry and the vertex? Are you finding the x-intercepts using the quadratic formula? Are you finding a specific output given an input? Draw and label a diagram when applicable. I do think that's a very helpful thing to do. Define all your variables you introduce, and then look at your answer and ask yourself, is this answer possible? All right, you may find that your answer is not possible because it does not fit with the facts presented in the problem. This is very important, and one reason why we shouldn't hate word problems. Word problems give us context, and context allows us to see if we're doing something the right or wrong way. And as always, finish with your solution with concluding statement. More so with this is I want to make sure you include units. Make sure you're including your units in your solution. Sometimes if we're doing a multiple choice problem, we can eliminate an answer choice just by paying attention to the units. So let's get started. Okay, so we're going to get started, and the way I'd like you guys to do this is we're going to read the question, you pause the video, you try and solve it yourself, and then you resume and you're going to check your answer. Okay, so a small independent motion picture company determines the profit P for producing N DVD copies of a recent release is P equals -200 N squared plus 3 4/10 N minus 16. P is the profit in thousands of dollars, and N is the units in thousands of units. So that's key to think of here is whatever we get, this is actually in thousands. So how many DVDs should the company produce to maximize the profit, and what will the maximized profit be? This is a very real world scenario with profit and businesses. We make too many DVDs, we're losing money because they're not going to all get sold. We don't make enough DVDs, we're losing out on making profit because we could have sold more. So you're going to try to figure out what this is by finding the maximum profit and number of DVDs. That keyword there is maximize. Okay, so pause this, try it, and then we'll do it together. Okay, so this is what this would look like on a graph. If we graph this, the maximum point is right here because this does have a maximum, and this is also our vertex. So what this problem was asking us to do was asking us to find the vertex by finding the maximum outcome. So the first thing I always like to do is determine what x and y is in the situation. So your x value in the situation is the number of DVDs you are making. The y value in the situation is your profit. And the easiest way to do this, you can always read it, but just look here. This is where our x's usually go, and this is where our y's go. So that's easiest. So how many DVDs should the company produce? That means the DVDs is our x value. We want the x value at the vertex. That's what we're trying to find. We know we can use the formula for the axis of symmetry of -b divided by 2a. So you could plug in -3 4/10 divided by 2 times -200. If you plug this in to your calculator, you're going to get 85. Now this is not 85 DVDs, this is 85,000 DVDs. Okay, so that is going to be our maximum number of DVDs. Now you're going to put this in as 85, that's fine, but we understand that's 85,000. Okay, so that is how we find it by hand, or you can always look at the graph. You can look at the maximum that way. All right, so this is 85 DVDs. If you were going to find the maximum profit by hand, you're going to take that 85 and you're going to plug it in for the number of units of DVDs. So we're going to plug it in for these N values. So we're going to come back over here and we're going to say that profit is equal to this equation, but now we're plugging in 85 for the number of units. All right, and if you do this, again, I highly recommend plugging it into a calculator. We end up with a profit of $128,500. Okay, so we're talking big money here. So this is our profit. This is our number of DVDs we are buying or making. Okay, make that a little bit neater. Does that make sense? So you can look at this, you can do this with the calculator or the graph, and I'm sure some of you did, or you can always do this by hand and make sure you understand that here we're finding the x value of the vertex, and here we'd be finding the y value of the vertex. Okay? All right, next question. Next question, the demon drop at Cedar Point in Ohio takes riders to the top of a tower and drops them. A function that approximates this ride is h equals negative 16t squared plus 64t plus 60, where h is the height in feet and t is the time in seconds. How many seconds are riders on the ride from start to end of drop? Now there's a key thing here. This plus 60 means that our riders are already starting at a platform 60 feet in the air. So our riders are going up and then they're dropping down. So that would be my little sketch, my little diagram to represent this. And what we're looking for is how many seconds they're on the ride to the end of the drop. So pause this and then we're going to resume and you're going to check your answer. Okay, so here's a graph, and this is an example. Here's our little platform. This is where we're starting. The ride takes us all the way up, and then it drops us down. So what this is asking for, it says how many seconds from start to stop, this is asking for an x-intercept, okay? So this is asking for when the y value is 0. So it wants to know what is the x value for time when y is 0. And to know this, we have to recognize the x and y values here. X in this situation is time, height is our y value, okay? So if we want to do this by hand, basically we're saying, all right, well, when y is 0, what is x? So we can plug, we know y is h actually. So we're going to plug 0 in for h, negative 16 t squared plus 64t plus 60. And when we do this, we're going to use the quadratic formula. All right, I am not going to work out the whole quadratic formula for you. You guys know how to do that. So after we do this, we should get two answers here. We're going to get an answer where from right here, where t is equal to a negative number, and then we're going to get an answer for right here, where t is equal to a positive number. We are not going to take the negative answer because we cannot have negative time. We are going to take the positive answer, which is 4 and 784 thousandths of a second. Okay, so this would be the time we need it, the time we were on the ride from when the ride started here to when we dropped to the ground. Okay, so you could use this using the quadratic formula, or you can use your graph. Yes, you are going to have to round on this one. Okay. All right, the next problem we are doing is a model rocket is launched from the roof of a building. Its flight path is modeled by h equals negative 5t squared plus 30t plus 10, where h is the height of the rocket above the ground in meters and t is the time after the launch in seconds. We want to find the rocket's maximum height, how long it will take to reach that maximum height, and at what time is the rocket 10 meters and 5 meters, okay? So pause, figure out what it's asking you, and then, okay. So in this problem, it is actually asking you for both the vertex, and this is not an x or y, x-intercept. This is asking you guys for the input when the output is 10 and 5. Okay, so the first thing I would do is let's define x and y. All right, x in this situation is time, and usually that's going to be the case. Y is our height in meters, okay? So, the rocket's maximum height, we're looking for h in the vertex, out of the vertex, or the y value out of the vertex. How long it will take to reach that maximum height, we're looking for time, which we know is the x value from the vertex. So, it's actually easier to start with B and then go back and answer A. So to find the x value, or time in this case, we're going to do negative B divided by 2A, which is negative 30 divided by 2 times negative 5, which comes out to be positive 3. So it's going to take 3 seconds to reach its maximum height. All right? To find out what the vertex would be, what that height would be, we're going to take that 3 seconds and plug it back into the equation. So we're going to find, well, what is the height after 3 seconds? So we're going to do this, and we're going to get our height is equal to 55 meters. So we found the height by first finding how long it would take to get there. That is our maximum here. You can always look in the graph and you can find 355 that way. All right, and again, we can put these in our calculator. I know I'm not working them out step by step, but I'm hoping you guys understand that these calculations can be done in the calculator or by hand. All right, now this part's a little tricky. At what time is the rocket's height 10 meters and 5 meters? So essentially it wants to know what is t when h is 10 and what is t when h is 5. So there's two ways to do this. Basically, we could use the graph. That is always a viable option. Or again, we're going to use the quadratic formula. Okay, so the first one, I'm going to plug 10 in for h, because this is our h. So 10 equals negative 5t squared plus 30t plus 10. So we're going to set this equal to 0, and I'm going to subtract 10 from each side, which is actually going to cancel that out. So I have 0 equals negative 5t squared plus 30t. All right. And this one actually can be factored. So I'm going to factor out a negative 5t, and that leaves behind a t minus 6. So I'm going to set both of these equal to 0. All right, this one I'm going to divide by negative 5, I get t equals 0. And then I have a t minus 6 equals 0. I'm going to add 6 to each side. I get t equals 6. So I have 2 times when the height is 10 meters. I have at 0 seconds and I have at 6 seconds. Okay, so at 0 seconds was our starting point. Okay, and 6 seconds is where it's coming down, but it's not quite at the ground. So it's at 10 meters at 0 seconds and 6 seconds. Okay, now to find out where it was 5 meters, this one you will have to use a quadratic formula, and I'll actually work this one out. Okay, so I'm going to do this over here on this side because I'm running out of space. So we'd have 5 equals negative 5t squared plus 30t plus 10. I'm going to subtract 5 from each side. I have 0 equals negative 5t squared plus 30t plus 5. And I have a, b, and c. We're going to plug that into x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So if I do this, I get negative 30 plus or minus the square root of 900 plus, what is that, 25, 100, all over negative 10. So 900 and 100 is 1,000. So the square root of 1,000. So I have negative 30 plus or minus the square root of 1,000 over negative 10. And the square root of 1,000 we know is that a perfect square? Let's find out. I don't think it is. I might be having a little brain blip real quick. The square root of 1,000, that's a perfect square. No, it's not. Square root of 1,000 is a crazy decimal. Okay, so we're going to put it in our calculator like this. I'm going to move this over here now so I have a little more space. Had a totally like brain blip there, but we're going to put in negative 30 plus the square root of 1,000 divided by negative 10. And we're going to put negative 30 minus the square root of 1,000 divided by negative 10. Okay, we're going to put each of these in our calculator, see what we get. All right, so I'm going to take a second. I'm going to go into Desmos. I'm going to type them in. Hold on. So our first answer we get is negative, and we're going to have to round here. I'm going to round to the nearest thousandth. Negative 162 thousandths. My second answer, that's what I do plus the square root of 1,000. When I do negative 30 minus the square root of 1,000, my second answer is 6 and 162 thousandths. Okay, so we have two answers here. All right, we are not going to select the negative answer because we cannot have negative time. And again, we're solving in seconds. Okay, we are, however, going to select the positive answer. So even though this had two answers, we reject the negative and we say that this was at, the rocket was at 5 meters at 6.162 seconds. Okay, so again, this is also knowing to plug in for the height and solving using the quadratic formula. All right, so the first one we could solve with factoring. The second one we definitely used the quadratic formula. I know it was a little bit long on that one, but I thought it was good to work that one out. All right, the last problem. A water balloon is catapulted into the air, so the height h in meters after t seconds is h equals negative 4.9 t squared plus 27t plus 2.4. All right, so you're going to answer all four. How high is the balloon after 1 second? How long will it take the balloon to reach its max height? What is that maximum height? And when will it hit the ground? All right, so let's go through this one. With this problem, what we see is the balloon is launched. It is actually launched from already 2.4 feet, or not feet, are we in feet or meters? Meters in the air. So it doesn't start at 0, okay? So first question, how high is the balloon after 1 second? So we need to define x and y. X is time, y is height. Seems to be a pattern here. All right, so what this is saying is if the time is 1 second, what is the height? So this one's pretty simple. If you want to do it by hand, all you have to do is plug in 1 for all your times. And with that, we end up getting that the height is 24.5 meters after 1 second. And you can also come to your calculator and you can find, all right, when x is 1, when the time is 1 second, what is your height? So 1 and 24.5. So this one you were just given an input, you plugged it in, you found the output. Super easy. How long will the balloon take to reach its max height? Right here tells me I'm finding the vertex. All right. How long tells me I'm looking for t, which we know is the x, so we can use x equals negative b divided by 2a. So negative 27 divided by 2 times negative 4 and 9/10, which if we go put that in our calculator, we're going to have to round here. We're going to get 2 and 755 thousandths of a second. So it's going to take that long to reach its highest height, which right here we see is our maximum. Okay. And then what is that maximum height? Same thing here. We're going to take the equation and we're going to plug in what we got for that x value. And again, I'm not going to recommend anyone working these out by hand. We're not testing can you multiply decimals, we're testing can you solve quadratic equations in real world problems. So we do all this, we put that in our calculator, you end up with 39 and 594 thousandths meters. Okay, so that is our highest height before it starts descending. All right, so again, this is finding that vertex, finding the x, plugging it in to find the y. And then when will the balloon burst and hits the ground? This is when we're looking for that x-intercept. And we know that because when it hits the ground, the height is 0. Anytime something's ground level, height is 0. So what we're doing is we're looking for time when it's 0. So plugging it in, 0 in for h, and then again we would use that quadratic formula, and I'm not going to work this one out for the sake of the length of this video. All right, but when you would work it out, you would actually get 2 answers. Again, you would get the one we're going to accept, which is the 5 and 598 thousandths of a second. Okay, or you would get a negative answer, and we know we are not accepting a negative answer because you cannot have negative time. Okay, so that would be how we calculate that one. And again, I know you guys can do all this on the graphing calculator. It is important though to make sure you understand how to do them by hand and using our formulas, and you're familiar with those formulas. I hope this helped you guys, and good luck.